Hi YouTube, welcome to another video review. I'm going to review this time something different that I've never reviewed before. I'm going to review what the inside of a microwave looks like. This microwave, it still functions, but there's a problem with the door latch, unfortunately. So it can no longer be used, but the parts are still good. So I'm going to do this very cautiously. Those of you that remove the cover like I have here, removed from this microwave oven, do be careful and make sure it's unplugged from the wall outlet. But I'm sure people are way to know that. So to make sure to be at a point, you must unplug the unit first. Never work on a microwave or any other electronic item with it plugged in for your safety as well as its own. So this one's been unplugged for ever since Sunday of this week. It's been about 4 or 5 days ago. So I'm sure whatever charge has bled off. As with most electronic items of this type, there is a capacitor associated with it. So the capacitor of this particular machine is a little different. The capacitor of this particular unit, I'm gonna move it. This is what the inside of a microwave looks like. I'll give a flashlight so I can see it. You can see it. There you go. This is what the inside of the microwave oven of this type looks like. This is a General Electric 1.2 cubic feet 800 watt microwave oven from 2007. This microwave is only about 4 years old, and everything still functions. Yeah, put the light out somewhere. Unfortunately, I gotta hold the light because there's not very good light in this particular bedroom. Trying to find a good position to put the light at, so you can see what everything looks like. Plus, you can see it on YouTube because YouTube makes it dark. There we go. Got it. Now, first of all, let me point out a very important safety precaution that you should always take. Behind this plastic cover is the capacitor. The capacitor holds a very big charge, up to 500 volts, I believe, 5,000 volts, I believe. That capacitor can hold a charge for probably hold the charge for up to a year or so, I would say. But I would say pretty safely. I assume pretty sure. Never assume that it's bled off completely. I assume this one will bleed off on its own, so I'm kind of not messing with it. I'm being very cautious. Because even if you discharge the capacitor can still have an electric charge to give you a shock. It can loop back to it. So you kind of have to do it more than once. And be sure do not touch the terminals of the capacitor with both sides, with a jumper with two sides like that. That's not the capacitor, but there's a thermal cutoff switch. But don't touch the capacitor. Leave the capacitor's terminals here and here. Don't touch the negative and positive at the same time, like you would. Treat it as you would a battery, so you don't get electrocuted. First of all, I'm going to describe the parts, and I'll tell you how they function the best that I can tell them. You get a pointing device here that's safe to be used with electricity. This is my tester. It's safe for me to touch. This is the capacitor, and there's 3 wires running to it, as you can see here. These 2 wires go up to the magnetron, and 1 goes to the transformer, and a 3rd one yet goes directly to the magnetron, and 1 goes directly to the capacitor. This one goes directly to the magnetron. the one here. This one goes from the capacitor. This one goes from the capacitor to the magnetron. This one goes from the transformer to the capacitor. This is where the power comes in from the capacitor, from the transformer here, not the capacitor. And then it goes through it to go back to this little wire here that I showed here, to the positive side of the magnetron. This is the negative side. It goes back to the capacitor. This is a diode, which its purpose is to make sure that it loops electricity. It grounds the electricity through the chassis so that you can produce voltage at this power supply. This is the transformer, the main power supply transformer. There's more than one, but this is the main one. This is a high voltage transformer. This produces up to 5,000 volts, I believe, depending on what size your microwave is. And it can shock you because the capacitor does run through this. So do not touch this with your bare hands without first discharging that capacitor, especially after you unplug your microwave. This is the input side of the transformer. This is the main power line. There's two of them coming in, the fat ones. The fat ones, if you can see. The fat ones, as you can see here, that's fat. You can see it. Two fat ones on the main power lines, and the thin ones are the circuit lines going back to someplace else. This goes underneath the microwave where the turntable motor is. Now this thing right here that you've been looking at, and I never told you about, is the magnetron. The magnetron is a radio transmitting device. There's a coil here. One set, two sets. This coil produces it's a filament. This produces this takes the high voltage from the capacitor, for the transformer to the capacitor, to produce a radio frequency radiation energy. Microwaves are not nuclear. They do not make any nuclear energy. They just make radio waves, like a regular telephone or a router does. Actually, it's the same frequency as a router. So that's why they caution you when you have a cell phone to not put it close proximity to the microwave, because this can interfere with cell phones or certain wireless networks. So that's why they made it higher. That little device that I'm pointing out here is mine's flashlight stay put, is the thermal cutoff switch for the magnetron. If this magnetron, the cooling fins that I'm pointing out here, if you can see it, gets too hot, this turns the power off to the entire microwave to avoid this overheating, because fires do happen when these things get hot. And the other one, this is another one for the cabinet. So if the cabinet gets too hot, like if there's a fire, it will turn the power off too. This is a cooling fan. It's okay to touch it, because it's not going to hurt anything. That's not the high capacity side. High capacitor is underneath. This is easy stuff. It's a cooling fan, which makes cold air from the intake back here to cool your magnetron. Now, this is your relay for your microwave. This relay is mounted here. Some are mounted on the floor. Some are mounted on this little plates. Some are mounted here. This one's mounted on the board. There's a transformer right here. That's a power supply transformer. You can see it for the microwave oven. There's two transformers, as I mentioned. More than one. This is the little one. This is the main power supply transformer for the magnetron mainly. There's three switches. One's primary, and I believe the primary one's on the top. I think the primary one's on the bottom according to the schematic. Could be on the top or bottom, I don't know which. One of these is a primary. This is a secondary. That's the monitor. Monitor means this light will come on when that switch is open. And when the switch is closed, the light will turn off. But when the magnetron, when it activates, it closes that and bypasses that switch somehow to allow the light to operate, even if the microwave is when this is activated. When the relay transmits power. Now here is the safety tips you must know. Safety tips that you must note. I do not stress this enough. Do not, I repeat, do not touch that capacitor terminals with uninsulated tools. Just in case there's a charge, you can hurt, and you can get killed. It will knock you on your butt, and it will put you in the hospital. It's not something you want to get shocked by. And plus it will damage the microwave and render it non-operational because of the electrical surge. Anyway, and if you do not feel comfortable about doing this to your microwave, don't do it. Don't do it to yours. Don't even do it to a discarded one. Don't take an old microwave like from 1971 or 60s or an old radar range or something and try to take it apart because of this capacitor. And them are a lot bigger than this one, and they do not have a bleed-up resistor. This one does have a bleed-up resistor built in there to bleed off the electricity, just in case this thing gets shorted. This microwave is General Electric, as I mentioned. It's fully digital. It's display, and that's a clock and a door. See the perforations in the door? You can look right in it and not to get cooked because the waveforms that the antenna makes on that magnetron is too big, too small, too big to fit through those holes theoretically. So it's like a cage. It's made of copper. It's made of a special copper material. Of course, it's painted white, but it is made of a special copper material designed to dissipate microwaves, and it reflects inside. Here's the label that tells you, it says what to do, how to discharge the capacitor. I am not going to take off the magnetron, because the magnetron is hard to take off with one hand. And plus, I'm not going to risk damaging the magnetron itself, just in case I need it for another microwave. The antenna is located in this plate, about the size of this little stick. And it sticks right in there like so. It looks like this stick. Actually, it looks like this probe. It looks exactly like this probe, except there's a little tip and a little hole at the end. That's where the antenna is located. It's surrounded by a shield and a ceramic covering. It used to be made of glass. This one probably isn't, judging for how cheap it is. It is an LG magnetron made by LG, and it's a 2M2813098. MB. This one is only for, and this label is for sound dampening. See this? This, aim the camera up please. This is for sound dampening, to make sure that it dampens the sound of the microwave. Well, that's it, and I'm going to stop, because YouTube has a limit. Until I'll see you later. Goodbye.